So if this is amount of data, amount of training data, this is the N, the training data, and this is your test error, E test, the E validation, whatever. Then as you increase the training data, so this is your, let's say this is your performance your accuracy, that we call it accuracy. This is accuracy. As you increase the data, the accuracy starts improving very drastically on traditional classifiers. Then, after a point, if you increase the data further, the accuracy does not increase with that amount. It increases with very little amount. Make sense? In neural networks, if you have small data, accuracy may go like this, but then it starts. So the traditional classifiers, the classifiers other than neural network, somehow they have a capacity of utilization of amount of training data. You give more and more training data, it is good, but at a certain limit after that, if you supply more and more training data, the training data stays like unutilized. Okay, theoretically, why is that? It's undiscovered. This is what is happening. Neural network is able to utilize more and more data. So in today in the field of big data, by big data I mean we have a lot of data. Now you have cameras, sensors, recordings everywhere. A lot of data is available today. A lot of data is available today. That big amount of data will be underutilized if you go and apply the traditional classifiers. One thing. So neural network actually utilizes a lot of data. If a lot of data is available, you should be utilizing that. And neural network is doing that. And that's a practical observation. This is what is happening. Why it is happening, I don't know. So second observation. Neural network तो बहुत पहले से introduce हुए हैं. Why they become very famous in the recent, let's say 5 or 10 years, they become a whole field, deep nets. Now we know what deep neural network इसको कहते हैं, लेकिन these are neural networks. Deep neural networks भी neural networks with a particular property. Why they become very common today? Because आज एक तो training data बहुत ज़्यादा है to justify that neural networks should be used. Otherwise, I mean, the traditional classifiers are okay. They are very good. They are comparable. But with a lot of data, neural network practically is incomparable. Practically it is sitting above. Second, traditionally, अगर आपके पास बहुत ज़्यादा data था भी, the training process का जब हम describe करेंगे next lecture, the training process is very slow. It is stochastic gradient descent that is being optimized. A lot of weights, a lot of complicated classifier at the end of the day, and the training takes a lot of time. Traditionally, we were not having the computational power to afford the training cost of a neural network. Today we have GPUs, we have very recent hardware, and people afford the training cost at the gain of a big jump in accuracy. So today we have data, we have computational power. So neural networks, they like reborn and supersede everywhere practically. I'm not discussing each and everything, anything theoretically, because there is a no freelance theorem. Nothing is good. Nothing is the best without seeing the data. You cannot say that. The same goes for neural networks. और by the way, अगर आप मुझसे कहेंगे मेरे पास कुछ मैं classifier choose करना तो कौन सा use करूँ? तो I'm unanswered. You tell me something about data, and then I will be able to tell you. For example, आप मुझे ये बता दो. I have 30 million examples, and each data point has dimension, let's say 10. Now, okay, 30 million examples, big data, a lot of it neural network. So I have decided based on data information. Make sense? So they are performing well because of availability of a lot of data. They somehow are able to utilize the more available data. But their training process is slow. Now with accelerated hardwares, with very sophisticated hardwares, now you afford that. And even some deep neural networks, they take months and months to train. Actually, Amazon Web Services, AWS, if you have listened, it's the cluster that is just for deep nets. It's just training neural networks. It is doing that. I mean, it is training neural network, computing weight and stuff like that.
तो जो ये traditional classifiers हैं, ये big data के ऊपर रुक क्यों रहे हैं? मतलब reason क्या है?
No answer. We do not know. They have some capacity of utilization, and people come up with that they do not exceed to this limit even after supplying a lot of data. And neural network somehow is. ये ऐसा नहीं है कि ये बिल्कुल रुक जाते हैं. They gain performance, but the gain is very slow in compared to the neural networks. समझ आई? Why is that? People are discovering this.
That makes sense. That's okay. Neural networks actually classifiers को ही हमने मुझसे तरीके से उसको arrange किया है और लगा के तो फिर तो हमने तो हमने
लेकिन there are other ensemble methods as well जिनसे आप classifiers को combine कर रहे हैं. इसका एक बड़ा fixed architecture. Why this particular ensembling methods are there? Why this particular ensembling method? ये भी ensembling है. Why this particular ensembling method in this particular way? इसकी मिसाल मैं आपको यूँ दूँगा कि यानी अगर आप वाई का क्वेश्चन करें तो मैं मिसाल आपको यूँ दूँगा कि यासिर अबू मुस्तफ़ा का लेक्चर है, लेक्चर नंबर 10 मशीन लर्निंग में न्यूरल नेटवर्क्स पे. उसमें बड़ी खूबसूरत एग्जाम्पल दी उसने क्या है कि मैं कंसल्टेंसी कर रहा था एक बैंक की, तो उसमें क्रेडिट कार्ड अप्रूवल को हमने क्लासीफाई करना था बेस्ड ऑन हिस्टोरिकल डेटा. सो कोई क्लाइंट आया, उसका इंटरव्यू लेते हैं, जो भी है इंटरव्यू लेंगे या उसको फीचर्स रिकॉर्ड करते हैं, फैमिली इन्फॉर्मेशन जो भी है, उसकी रेजिडेंस कितनी है, कितनी से सैलरी कितनी वगैरह वगैरह, और एंड देन दे ईदर अप्रूव लोन फॉर हिम और नॉट अप्रूव लोन फॉर हिम. They call it credit worthy or not credit worthy. Make sense? So that's a bucket classification based on certain features that they collect by interviewers, survey or whatever. और उनके पास हिस्टोरिकल डेटा कुछ था यार, लोगों ने जब ये लोगों की प्रॉपर्टीज थी और उन्होंने क्रेडिट लिया था, तो they do not return, they become credit defaulters and stuff like that. So should we give credit to people or not? तो इसने कहा कि मैंने ये प्रॉब्लम से सॉल्व नहीं किया. I designed a neural network and the neural network works. और मैंने ट्रेनिंग क्रॉस वैलिडेशन जो भी मैंने किया तो इट वाज वर्किंग वेरी फाइन. जिनको क्रेडिट मिलना चाहिए था उनको वन देगा था, जिनको नहीं मिलना चाहिए उनका टेस्ट डेटा जो मैंने सेपरेट किया हुआ. एंड वी वर एबल टू डिप्लॉय दैट कि नया बंदा आता है तो उसको आप उसके क्रेडेंशियल्स देखें और उसके बाद वो क्रेडेंशियल्स आप न्यूरल नेटवर्क को दें, एंड न्यूरल नेटवर्क एट द एंड ऑफ द डे विल टेल कि वेदर दिस पर्सन इज क्रेडिट वर्दी और नॉट. दैट वाज वेरी गुड. मेरी तरफ से बड़ा वेल डिजाइन था. ओके, दैट वाज वेरी विशियस. दैट वाज गुड. तो मीन टाइम वो जो भी बैंक के जो भी रिसोर्स पर्सन थे वो आए तो वो कहते हैं कि आप एक्सप्लेन करें कि ये क्रेडिट अप्रूवल और नॉन अप्रूवल कैसे करता है, हाउ द न्यूरल नेटवर्क इज वर्किंग, तो एक्सप्लेन दैट. तो उसमें बड़ी उसने खूबसूरत बात की है. तो उसने कहा कि मुझे ये कोई ऐसी बात नहीं थी कि वो ये चेक करना चाह रहा था कि इसको मशीन लर्निंग आती है या नहीं आती. असल में जो प्रॉब्लम थी वो ये थी कि वो ये जानना चाह रहा था कि जब मैं एक क्लाइंट को कहूँगा कि यू आर नॉट क्रेडिट वर्दी, तो वो क्लेम करेगा कि प्रूव इट, हाउ हैव यू जज्ड दिस, एंड आई शुड एक्सप्लेन हिम कि बिकॉज ऑफ दीज फैक्टर्स. नाउ एक्सप्लेन मी द प्रोसेस ऑफ हाउ न्यूरल नेटवर्क सेज दैट समवन इज क्रेडिट वर्दी, नॉट एक्सप्लेनिंग द स्टेप्स बिट बाय बिट. तो उसने कहा कि यार फिर हम यही एक्सप्लेन कर सकते हैं कि देखें ये 0.7 है, 0.7 0.2 से मल्टीप्लाई है, एंड below than 0.5, so lambda is below 0.5, so it's not credible. उसको human terms में explain करना, which is called explanation and understanding. This is not yet achieved. Maybe achieved, may not be achieved, depends. So this is working. If you want a bit-by-bit explanation in human layman terms, this is not available yet. Make sense? Well, I mean, if this is undiscovered, this is a bad thing because this is undiscovered. But it is a good thing. There is a potential for a lot of research in this field. And there is a convolutional neural network course on Stanford by Fifili. They actually come up with some explanation of different layers, different neurons and their visualizations and stuff like that. A partial explanation. Sorry?
So video lecture?
Yes, video lecture.
Stanford or what's that?
Stanford. It's
Fifili?
Karpathy and Fifili. It's a convolutional neural networks for visual recognition. Anyways, let me describe the structure of neural networks with this. By the way, this is a very good thing. It gives the be 1 or 0, then I combine in a particular way. At the end of the day, I want to learn these weights, and these weights, and these weights, and these weights, so that this example, for this example, the output should be 1 if the label is 1. And for this example, the output at the last, the output should be 0 if the label, the training label is 0. Come up with these weights and these weights and these weights and so on. So again, the problem is coming up with the weights that transform X to its label. That map X to its label. Make sense? It turns out that if you use these 0-1 kind of things and ANDing and ORings, the problem becomes combinatorially hard. It becomes all combinatorics. I mean, if this is 1 and this is 0, this is 1 and that is 0, and all of these, this is combinatorially very, very hard. So a fix to that is, rather than thresholding, pass the confidence out. Rather than thresholding it, pass the confidence out. And use this function, not just the sigmoid, use any function that is differentiable. Why differentiable? To get the benefits of the gradients properties. Gradients, they tend to give the minima or maxima at certain points. So to come up with to utilize the property of gradients, let's have these functions inside the neurons that are differentiable. I mean, this is to impose simplicity for the derivation. Make sense? And one choice is sigmoid, but there are other choices as well. One choice is tan H. I will explain this tan H in the next lecture. One choice is ReLU, rectified linear unit and stuff. These should be differentiable. And the output of this function is passed as it is rather than thresholding and stuff. At the end, at the last unit, we should have a sigmoid because at the end we need a probability. We need to classify. The last unit should be a sigmoid. पीछे जो कुछ मर्जी हो रहा है, at the end it should give me a result very close to 0 or very close to 1. Make sense? So here are the components of, and by the way, this function inside the neuron that is applied on this number everywhere, this is called activation function. This is a technical name of it, activation function. So following is the structure of the neural network. I'm just writing one neural network here. This is first layer. This is second layer. This is third layer. This is fourth layer. This is fifth layer. And this is sixth layer. The last layer is sometimes called the output layer. For binary classification, the output layer just have one neuron. This is the input. Yes? All the input is fed to the first neuron, then to the second neuron, then to the third neuron, and so on. Make sense? All these they are fed to this neuron. All these are fed to this neuron. लेकिन जो इस न्यूरॉन को हम दे रहे हैं उसके वेट्स कुछ और हैं, इस न्यूरॉन के अपने वेट्स हैं, इसके अपने वेट्स हैं, इसके अपने वेट्स हैं, इसके अपने वेट्स हैं। Make sense? इसके वेट्स कितने? D+1. Yes. इसके वेट्स कितने हैं? D+1. इसके वेट्स कितने हैं? D+1. इसके वेट्स कितने हैं? D+1. Make sense? Now the